Hi. Uh, Today we are going to discuss about a different topic, which is reinforcement learning, which is another form of learning, something little bit similar and somewhat different from the main types of machine learning. Like first thing that we have learned uh, was about supervised machine learning, and then the unsupervised machine learning. And this is also another form of machine learning, uh, which is mainly used for uh, applying machine learning in real-time applications where you have to learn from the environment and respond at that moment, where you can't have that much uh, labeled data with it. So we will see what we are going to discuss about the today's lesson. So with supervised machine learning, what we have learned was how to map the X or the input variables or the independent variables to the dependent variables. Right. So here the dependent variables are the labels that we generally used to train the machine learning model in supervised machine learning. Uh, and in the unsupervised machine learning, you may remember that we don't have any y labels, but we are creating some intuition or create some classes, trying to figure out the classes in the X dataset, right? But in this case, with reinforcement learning, we are not giving the y labels like in the unsupervised machine learning, but here the machine learning itself or the algorithm itself has to decide what to do based on the real world applications, where the machine learning happens itself while it is running in the real time. So that is the main difference between the supervised machine learning and the reinforcement learning. In the supervised machine learning, you get the data set and you train the model in the offline manner, and then you can deploy the uh, trained machine learning model in the system that you want to run in the production. But in reinforcement learning, you do the learning process while the system is running. So that is why it is a bit uh, critical, right? So if you try to learn something in the real world where it may be mission critical, so then this is somewhat special when it's related to supervised machine learning, obviously, right? So with supervised machine learning, you can train after you have trained, you can find the test errors, and then you can plan for handling errors, and you know what is the precision recall and all the performance of the model. And because we know the environment, you can uh, deploy that supervised machine learning model uh, with much trust on it, right? So but when it comes to reinforcement learning, you have to trust on the reinforcement algorithm, right? So you have to make sure it is learning properly, and making mistakes is also uh, a normal thing when it comes to the reinforcement machine learning, especially in its initial stage. So you have to have kind of different mindset when you are trying to run reinforcement learning algorithm. But however, in the current world, because of the uh, improvements that you might have seen in the gaming engines, right? So in the computer games, you might have seen the 3D animations and all the physics that is there in the real world can be simulated in the gaming environment. So with fortunately, thanks to this gaming industry, now we have a lot of virtual environments you can where you can uh, train a machine learning model with reinforcement learning in a simulated environment. Unlike in the previous time, now you can train your reinforcement machine learning model in a simulated environment so that it can uh, learn by making mistakes without running it in the real world where the cost may be high or it may be dangerous to run it in the real world in the first place, right? For example, if you want to uh, train a model, reinforcement machine learning model for self-driving cars, so it's not safe to train a new machine learning reinforcement machine learning model in a real car because in the earlier stage it may do many accidents which would kill people, so that cannot be allowed. So because of that, you can do it in a virtual environment easily where accidents or anything that happens in the anything that badly happens, the bad outcomes are okay in a reinforcement in the virtual environment, and you can do it even faster than it is done in the real time, where you can increase the speed in the virtual environment and train it faster and you can do it in the parallel way. So that is the advantage of using virtual environments, right? So in reinforcement learning, so let's see so why we are moving to reinforcement learning by using this kind of all these difficulties where you need to run it in the virtual environment, which is expensive, uh, with related to the well-known supervised machine learning, right? So, so reinforcement machine learning is generally used when you have some special requirements, something like this, right? So, for example, so this reinforcement machine learning is actually trying to the idea is that it is trying to mimic the problems where humans are making decisions, right, in day-to-day life. So in the supervised machine learning, you have a specific set of problems and you know it very well and you know the conditions or the independent variables and then you know the outcomes. But in the real world, in if you consider a real human being, we don't have such thing like supervised machine learning, right? So you study in the school, but most of the things that we have learned during our lifetime is learned in daily life, right? So you do mistakes and then you get punished, and then you do good things and you get rewarded, and that is how you are learning everything, right? So the if you can remember the time that you have tried to walk in the earlier days of your life, so that is a good example for machine learning for reinforcement learning, right? So first you try to walk and then you fall and then you learn why you fall, why you fell, and then you learn all those things. So I know you haven't done it with intention, so I am learning and so on, but that's what really has happened, right? So after some trial and error, then you have learned to walk, right? So that's how all of us have tried to learn, right? So that is common for learning the language, learning to speak, and all those things, right? So we make mistakes and then we get bad feedback, and in order to reduce the bad feedback, we learn, and when we do the correct thing, uh, we get rewards, and then we get happy with rewards, and when we try, then we try to practice the same thing again and again, more and more, and avoid the mistakes in the future, right? So that doesn't mean that we 100% avoid mistakes, right? So time by time, sometimes we try to uh, divert from the uh, convention, and we try to bypass that path, and sometimes we get successful, right? So sometimes we may get highly successful by uh, going out from the conventional path, and then we learn that this path is better, right? So and then we can continue on that, or then we may get punished, or we may get negative feedback. So then we determine that we should not do these things in the future, and then we uh, move only with the rewarded actions, right? Really, so here what we are doing is, so we observe the environment, and then we take the actions depending on what we have learned uh, from our experience, right? So this is, if you try to model what is reinforcement learning, basically this is what we are going to model. So we do some things, we take some actions, and by looking at the environment side. So first thing is that you look at the environment where I am the moment. So that is known as the, you're looking at the state, the environment, and then we take an action. And for that action, there's something get changed in the environment, right? So if you want to if you want some food, you in the earlier days you may cry, and you may have understood that then you can get milk, right? So from your mother. So then you uh, learn that behavior, and when you are hungry, then you try to cry, and because when you get feeded, then now you feel happy, and then you feel comfortable, then you learn that behavior, right? So but after some time, that you get to know that this is not the way to get the food, and then you have to do some other things, and then you had to come to this to learn these things and all those things, right? So then you have to uh, and take the food and all those things that you learn later in life. But uh, all those things happen with the time, right? So le- you take some actions, then you get some feedback, and with that feedback you change your policies. That means how you should take actions, and after the changes of these policies, then you take actions in a different way in different states of the environment, right? So the idea is that you want to try to maximize your reward, and minimize your uh, negative feedback, right? So that is what all of us are doing, right? So if you think about an organization also, the organizations are also like that. So they are driven by the profit, right? So if you if they try to do sell something, and if that goes in a viral way, they try to do it again and again, and make more profit. If that is not getting successful, then they will try something else, right? So 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 this is all of us are doing. So not only human beings, but if you uh, think about some primitive animal like a dog or something, uh, they are, if you can easily observe how they are responding to food, right? So when they are hungry, then they wag their tails and come to you, and when you feed it, so then they learn that behavior. When they need food, they come to you and wag his tail, right? But if you hit them or beat them, once they wag their tails, they will not do it again, so they will go to someone else who would feed them, right? So that is how they learn. But the thing is that they learn those behaviors with their experience, right? So you have to take action and see what happens in the from the environment, right? So you have to get the feedback, what happens, and depending on the feedback, you change your policies, right? So you change how you are going to take actions in different states. So that's all what we are going to mimic in the reinforcement learning algorithms. Right, so you are using supervised reinforcement learning or supervised learning when the results or the rewards, the ultimate rewards are cannot be easily seen in a short time. So that this is one of the reasons that we are using reinforcement learning. For example, say now you try to so let's take a business example. Say you are going to invest in a particular business, right? So particular share stock means basically you are trying to invest in a particular company, right? So you can't get the result immediately, right? So you may get some dividend in the next year or some, yeah, but still you don't know what would happen to your investment. For example, it may grow with in the next 10 years, or it may get bankrupt in next 2 years. Anything can happen. So you can't directly get the immediate feedback and decide whether this is the correct one or the wrong one. But you have to wait for some time to decide what whether your action was correct or not, right? So you have to decide beforehand. That means you have to think earlier uh, what would happen in the future, right? So your payoff or your reward is actually not the immediate reward that you get, like you get a very high dividend in this year. This is not only what we are looking at. We may get more dividend in the future, and the company share may get higher or it may get lower. All those things get affected uh, depending on our decision, right? So you have to take your decision based on the total full future return, right? So uh, full future reward, right? So that is something else. So you have, so this is one reason when we are using reinforcement learning. In the supervised machine learning, you can directly get the immediate reward or something as the y label, and then you can train the model. But when it comes to reinforcement learning, you can't only use the immediate reward, but you will have to wait for some time to get the reward. So that is, so then you have to estimate the future reward, uh, total reward that you would get uh, until the process is finished, and that is how you should calculate your reward, total payoff, or your positive feedback, right? And the negative feedback is also the same, right? So if you get for example, if you try to decide you select a particular degree program, right? So you don't know, you take that decision uh, not based on your immediate reward, right? So once you get selected to the university, so you may not get rewarded, right? So you may get markup followers or something, but you will not get rewarded immediately. So you would have to work hard, you have to do assignments, you have to do all those hard work, but you expect that after 4 years you will get the job that, and you will uh, get hired. So, and you will get hired in a company with, so you will get higher salaries and so on. So that is your expectation, right? So you can't immediately get the reward and think this is what we have got. So in these kind of scenarios, we have to use reinforcement learning, and there are situations like you can't get the data set immediately, right? So and or taking the data set is expensive or it's time consuming, right? So you have to and the field or the environment is changing, so you have to, the model has to learn continuously. So you can't get a label data set in a fixed way. So when the environment is changing, so that you have to learn according to the environment. So you have to build a model that can learn with the time. So that is another requirement when you are going to use reinforcement learning over supervised learning, right? And the other reason is that your payoff or your feedback or your uh, feed your reinforcement, positive, either positive or negative, is dependent on your action, right? So that means you take a certain action, and in the next time step, you will get some, and after that particular action, you will get some reward or punishment, right? So you get some feedback, whether it is a positive one or not negative one. So because these feedbacks are dependent on your actions, you can't generally use a supervised machine learning, because only when you are interacting with the environment you can uh, change the decisions and get the feedback, right? So for example, think it like this, right? So uh, you can't if you assume that your model is trying to mimic a human being, right? So you can be a psychopathic criminal or something, right? So if that is the case, whatever you do, the society will punish you, right? So whatever the thing that you do in that kind of policy, yeah, you are not a, uh good social fit, and the society will punish you. So you will understand it only when you are deploying that kind of model in the real world, right? So because most of the scenarios, if you get the data, so those data may be aligned to a normal person, right? So if your model is working bad, we don't know really whether what would be the uh, y values or the dependent variables or the feedbacks that you would get after that you execute after you execute a certain actions, right? So because of that, you can't generally get the data for an ordinary person and apply it to a data set. But once you deploy your model in the real environment or a simulated environment, then only you will understand how much reward, or either it is positive or negative, will be received. So depending on that reward, the model can learn whether to reinforce that particular behavior or reinforce that kind of actions in that kind of state, or whether you should avoid this kind of actions in that particular state, right? So if it is say like you are in a certain social situation, if you try to make certain kind of jokes, some people may get offended, or in certain type of social situations you may get rewarded, so they would like it, right? So once you understand your environments and the people around you, so which is the state, then you can decide what is the action, whether you should make jokes or whether you should not make those jokes, depending on the social situation, right? So in order to do that, you have to interact with the environment. So that is why we need reinforcement learning or supervised machine learning, right? And the other main reason is you have to balance exploration was exploitation. So we will say after several seconds we will discuss what is exploitation and the exploration uh, dilemma, right? So in learning world, we may hear these terms more and more, right? So these are some fundamentals about reinforcement learning, right? So what first, let's get to know what are the meanings of these terms. So those are not uh, the meanings that are obvious to these terms, right? So exploration means it is correct, right? Exploration means you are looking at the environment and learn from it. So that is the exploration, the common meaning, right? So that in the machine learning world, in the reinforcement learning world, it means uh, you do, after seeing a certain environment or a certain state, you take some action, and then then you will get some reward, right? So then you will start to learn more and more for different states, and for different states, for different actions you take, and then you learn uh, the action space, right? So for different action, what would happen if I would have done these actions? So you are exploring what are the things that would happen, how much, actually not the things that happen, what are the rewards that you, how much reward, that is positive, negative, large or small rewards that you would get after you take different actions for certain number of for the given states, right? It's more about learning, right? So when you are learning, you will not get much rewarded, right? So because you are taking the actions that you think that are not the optimum actions, right? So for example, when you are learning, you can make a lot of mistakes. So that is what's about exploration. Uh, but when it comes to exploitation, it is all about using the already learned knowledge to get the highest reward. So it's the exploitation means, so for before the exploitation, you should have some knowledge, or you should have some intelligence, or you should have some wisdom about the system, right? So once you have explored for a certain time, then you can increase the exploitation phase, where you can use this knowledge. So if you are very successful at exploration, then you don't have to do all those mistakes again and again to learn more, because now you know these are the correct things, these are the best actions that you should take to get the reward, get the highest reward, and then now you can uh, give lesser weight to the exploration. Now you can exploit what you have learned and get more reward, right? It is like our life, right? So in the earlier time, from in the 13 years in your school, you have explored, that means you have learned many things, but you haven't get any salary or anything. In the university also, you learn many stuff, right? So and then you go to the job, and the job, actually you will not uh, learn or study much of the stuff, right? Actually you will learn the job related stuff, but basic stuff you will not learn, right? So the mathematics, geometry, or any other calculations, how you do it, your programming skills, all those things, you have already learned it. So when you go to the job in the earlier life, in the last 13 years plus the university life, what you do is you explore, you focus more mainly on the exploration phase, right? So then you, once you go to the job, you should not stop exploration, that means you should not stop study, but your main purpose is using the exploitation means you use your knowledge, already acquired knowledge, and earn money out of it, right? So you get the reward for what you have learned in the later life. But in the machine learning, so you can't have it actually in two phases like that, right? So from the beginning, maybe in the, so you can actually balance these two phases, right? So in your machine learning model, so from the beginning, if you want to have some reward in order to sustain, or in order to maintain this production system, you should have some exploitation, right? And but minimum level in the initial stage, and you should more focus more on about exploration. So once your exploration has successfully got enough insight from the system about the environment, or you have learned a lot, right? So then you can give higher weight for the exploitation and reduce the exploration, right? if then you realize that your exploration, so then you realize your reward is getting reduced in the exploitation, then you should your model, excuse me, and when you find uh, that your reward is getting reduced significantly, the model should be intelligent enough to reduce the exploitation and start the exploration phase so that it can understand the new uh, environment. So there might have been some changes that has happened in the environment. So you have to learn about the states and the actions that you should take in the new environment. Sorry. And so that is the idea about reinforcement learning. So you have to like change the gears, whether it is exploration or exploitation. So when you explore, you would not get higher reward, you will get negative rewards as well, right? But when it comes to exploitation, you get higher rewards, but you will not learn well, right? So you have to balance all these two scenario phases because you can't focus only with one, right? So you have to do both. You have to learn and you have to earn. That is, when it comes to your life, the same thing applies for the reinforcement learning, where it has to. So it is like this. So let's say take some real world example, right? So say now you are using uh, certain using your reinforcement learning to operate a robo hand, right? So in the in the exploration phase, it would try to move your hand in different ways to touch or move a certain object, but the the success uh, rate of this process would be very low, right? So because you try to move your robo arm in different ways, different speeds, different angles, and see what would happen, right? So but once you have got successful at moving the object, then your model will learn this is the correct way to do it, and it would avoid the all the other uh, non-successful paths, non-successful actions it has taken, like moving the arm and the angles, the speeds, and all those things. And it would only focus about the uh, ways that are only very successful, and then it would move the object successfully. You will get a higher reward, right? So when you do the object movement correctly, you will get a higher reward. So that is what really we are expecting from the machine learning, right? So it's not about learning continuously, but our main objective is is the exploitation, right? So but in order to do the exploitation, we can't do it alone. You have to learn it. That means you have to do the exploration. So you can't forget the exploration as well, and you can't only focus about the exploration too without the exploitation. So then there's no value. So that is the balance that you have to take when it comes to exploration and exploitation when it comes to reinforcement learning. So this is also an open-ended question, right? So different algorithms they do it differently. So we are not going to deep into these algorithms. So we are going to learn about the fundamentals of reinforcement learning in this lesson. So let's see what are the examples of the reinforcement learning, right? So the one of the most commonly used application of reinforcement learning these days are controlling mechanisms of robots. Like I mentioned, if you want to train a robo arm, so in the earlier time, there were some analytical, uh, mathematical ways that it was used, like the control theory and so on. But the success of this control theory related uh, uh, techniques were not that successful, as you know, right? Because we couldn't simulate a humanoid robot, but with the reinforcement learning, with the help of machine learning, now you can train robots that are moving hands or moving their tires or the wheels, and do different tasks with by moving or interacting with the real physical world. So that is one of the main uh, application of reinforcement learning. So in the near future, actually, we will see how uh, the laborers that are using their physical labor to earn for themselves will get replaced with humanoid or specialized robots that are developed with these technologies, right? So that is because that is why you should give a higher attention for this subject, which is the reinforcement learning. So this will be the subject that is going to replace the uh, working people, right? So the people who are technically working at the site will get replaced with these techniques. And the other application is are using for computer games, right? So for if you want to automate how to play a certain game that you are doing in with the computer, right? So these days, in the upcoming future, the sports will get most of the sports will get be online or virtual games. So in order to play the virtual games, people would use virtual agents that are powered by artificial intelligence. So this is the reinforcement learning would be the uh, most suitable technique when it comes to playing games uh, with other people or other agents in technical terms, right? So that is another application, right? And when it comes to trading or buying and selling certain stuff in the financial markets, like commodities, like gold or stocks, company stocks, or some options, and there are different things that you can trade in the market. So when you are trying to predict the uh, future of the market, whether the price would go high or low, then you have to uh, then you can use the reinforcement learning to make predictions depending on the changing environment, how the prices would move, and then you can use these techniques to make profit out of it. Okay? And also, when it comes to manufacturing plants uh, or factories, you can the performance of the factories is very important for them in order to reduce the cost and maximize the profit. So there are different ways that they have tried to optimize the uh, these operations. Operations means how things are happening in physical way, and these reinforcement learning techniques can be used to automate them, and then you can use to learn how to do them in the most optimum way, right? So by looking at the outcomes, then you can modify the actions that should be taken depending on the state, and this can be reinforcement learning can be used to optimize the factory operations. This phase of like if you are working on a garment factory, whether you should color the things first and then store it in the storage for how long, and then what is then the action is taken, like the cutting the cloth or something, right? So how much time you should take it, what is the amount of time that you should take, what is the batch size that you should be using, those kind. I'm not referring to real information, right? So you get the point, right? So you can decide what are the things that you have to do, or what are the tasks that you have to do, and in which order, in which quantity, and all those things can be decided with machine learning by continuously changing them according to the principles of reinforcement learning. increasing the exploitation and also focusing on the uh, outcomes, which is known as the exploration, right? So by using these techniques, you can optimize the factory operations. So these are the main concepts that you have to learn about reinforcement learning, right? So the first concept is agent, right? So the agent is the one which is the intelligent part in the system, right? So where our algorithm is running and taking actions, so which is similar to the human being uh, who is making decisions based on the environment, right? So there can be many agents, uh, maybe working together as a team or maybe working against each other, like in the financial market, right? So each agent will work independently and it to try to maximize its reward irrespective of the other, irrespective of the rewards or rewards that are gained by other agents, right? So those are like independently running, uh, self-centered agents, right? So who are very selfish, right? So they would try to learn what are the actions that should be taken in a certain state, depending on the feedback that they receive from the environment, right? So the environment is where the agent operates, right? So agent see the state of the environment, so where the agent operates or take actions for certain things. All these things are happening in this environment. So that is the environment that we are talking about. And after, depending on the learning that the agent has taken, like after some time, he may have learned something and he may take some decision, right? So this decision to do this thing or the other thing may be a certain decision. That decision is known as the action taken by the agent. So which should affect the environment again, right? So once the agent takes that action, it would affect the environment again, and it would give the agent again some reward, right? So in the particular environment, for a given state, right? So in the given environment, agent can see what is the state that he is in at the moment. So for the for that particular environment, there are set of actions that he can take for a particular state, right? Obviously. So in the particular state, all the actions that he can take is known as the action space, right? So when the agent take actions, it would be an action which is in the agents, which is in the in the action space. Right? So the intelligence of the agent is defined by the uh, uh, correctness of taking the correct action from the from the action space. It's like this, right? So I have so I am the agent who is trading in the financial market. We have two actions, whether to buy the buy the gold or sell the gold. So those are the two actions in the action space. If I if I take the correct action, which is to buy it, so that means in the real world, when the price is getting higher, so then I have taken the correct action, right? So the other concept is observations. Observations are what the things that the agent see or the observe from the environment after taking the actions. So once the agent has taken a particular action, right? So the environment will get changed, and it would give him some uh, it would give some information about the environment to the agent. So those are the observations that the agent can see. So with all those things, with the actions of the agent and maybe due to the changes in the environment itself, or maybe the actions of the other agents, the environment may get changed. So once the environment is changed, the changed environment in a particular time is known as a state. So the state of the environment may get changed time to time or continuously, right? Depending on the environment, right? So the idea of the agent is to look at the state and take the correct action, which should give higher reward. So what is the reward? Reward is the feedback to the agent that uh, measures the correctness of the action he has taken. Right? It's like getting money for taking the correct decision. Say in the gold uh, trading market, if you have taken the correct action of buying the gold when the price is getting higher, not the price is currently getting higher, but in the environment where the price is getting higher after that, then he has taken the correct action. That means he has taken the correct prediction. Then he will get, then he can trade, sell the gold and get the profit. So this is the reward that he can get. Right? So in a robo example, you can say that if you could safely move the object from the source location to the destination location without much harm and without taking much time, so that is the then the robo hand will get a higher reward for moving that particular object in the correct way. So that is the reward that would be received by the agent. So if you look at the all the concepts that we have learned up to now in the single picture, this is how you can see. So this is the agent who is taking actions. So actions AT, which would affect the environment. Right? So environment is where the agent is operating. After these actions, the environment will get changed. Maybe just because of his actions, maybe depending on the environment itself, or maybe due to the actions of the other agents as well, right? So we don't know, but somehow the environment will get changed. Some things we can change, some things we can't change, right? The same thing applies for the reinforcement learning, right? So it doesn't mean that you have this ideal action that you can take, which should give the higher reward, but you can take it probabilistically, but you can't guarantee that you get a higher reward, right? So that is the nature, right? So that is why this subject has born the reinforcement learning, where you learn from the environment, where you get the observations, where the state, where it might have in the ST, now the state has changed from ST plus 1. So the action is taken in the time T, known as the AT, and the state has changed from, and then you have received the reward of RT, and the uh, state of the environment has changed from ST to ST plus 1, right? So this state change and the reward will be known by the agent after the action was taken, right? So in the T plus 1 time, the agent can take another action which will change the environment and get the reward RT plus 1, and the state will get changed to ST plus 2. right? So this should go again and again. The agent will learn how the environment works by taking certain actions and looking at the observations, how much reward he has received or whether it is positive or negative. And it would change its actions depending on the reward. Not so now let's see. Now we are not directly looking at the reward that you have received immediately, right? So we will see we what we are looking at from the agent's perspective is not directly at this reward, right? So we have to think in long term what would happen to the agent in future. If I take this action, I would move to a certain state. After going to that state, what would happen to me? If I would be in a greater position to make more rewards in the future, or the I would be having a catastrophe, right? So, like when you are selecting your degree, uh, sometimes you may find the degree itself is a bit difficult to learn. So, where the immediate reward is less, but after you have graduated, you will get higher salaries or some other you get to do your own business or some, but where you can get higher rewards. So you have to, if you have selected an easy degree, you would get immediate rewards which are very high, right? You would have a very comfortable life in the immediate future, but in the far future, you will have lesser rewards, right? Because you might not have learned what is required but to earn money or get social status or whatever that you are expecting from the degree, right? So this is so the reward is not the direct thing that we are looking at. What we are looking at is the total reward. Total reward means you have to take the rewards, right, from the and you have to add all of them until the end of time, right? So at the end of time is until the process is finished. Like if you are thinking about your life, it's like how much happiness or pleasure that you'd receive throughout your life by taking that particular decision of taking this degree. So it would be like what would you get immediately after you graduate, what would be the jobs, whether you should be happy with your job, whether you should get enough salary, whether you should have a good environment to live, you would have a good work life balance, whether you could have be able to manage your family life with it, all those things, whether you should have health issues, career related issues by taking that particular career path, everything that you have to decide it would happen after several years, right? So the return is not the immediate return that you would get like you would having a comfortable time in the university. So it may be like you would have a higher salary and you have a higher work life balance, you can manage your family when your children are uh, grown, and how you should end up with your retirement, whether you should would end up with some work related diseases after the retirement, everything that you have to think, right? So that is the total reward that you should consider. Okay, but the problem is okay, I'm not going to scare you, but sometimes there's a probability that there would be certain accidents and you would not live up to that particular time, right? So sometimes if we are if we are fortunate, we may be living up to the maximum lifespan of humans, like 70, 80 years. But if not, uh, what would happen, right? So sometimes taking the if you think that you would die after 4 years, actually, maybe you finding an easy degree or not taking any degree, maybe if you have some terminal illness or something. So if you have these things, don't get demotivated, right? So you don't give up. But what I say is that depending on the future expectations, you can take decisions, right? So if you hope to live a long time, you may be having a uh, hard time in the immediate future and get a higher reward in the long term, right? So because but we don't know about the future, right? So because of that, uh, we have a uncertainty. Uh, if you have learned about this in the investment or the in the finance, you would know that this is represented by a discount factor, right? So which is a discount factor where you would weight with the time as a polynomial, right? So for example, the if when you are calculating the future value of something, you calculate uh, the future next year cash flow by having by multiplying with the discount factor with the power t, right? If it is 1, right? So if you are getting 10% discount factor, the immediate uh, reward would not have any discount factor because you would definitely get it. But after you if the reward is given after 1 year, you can have a discount factor of 10%. So then the reward that you get after a year may be discounted by 10%. So it would be multiplied by 90, right? So the the next year the reward that you get would be multiplied by the discount factor of 90% multiplied by 90%, right? So it may be uh, so the reward should be multiplied with 81.81 uh, to map to the current return, right? So you can't directly add the returns that you expect in the future because the future is not certain. Uh, we may get our process may continue until the end of the time, but some or there's a risk that it may finish before the after some time. So in each time step, you have to uh, take a multi to take the uh, power incremented in each time step, the selected discounting factor, and then you have to multiply each of these rewards with the discounted uh, with the incremented discounted factor, right? Discounted factor is the power related with incremented with each time step, right? So this is represented by gamma. For the time t, it would be gamma t. For the time t plus 1, it would be gamma t plus 1. So it is multiplied by the reward for the time t plus 1. And for the time n, for the time t plus n, the reward t plus n would be received and it should be multiplied by the gamma to the power t plus n. So after say like uh, 80 years or something, 50 years or something, your your actual return would be almost zero because most probably you would not be living until that time, right? So if when it comes to a uh, when it comes to say like investing in your stock in a certain company, that company may not exist until that time, right? So because of that, you should be giving a higher weight to the recent uh, rewards, but you have to decide what is the discounting factor that you are using, right? So sometimes that you can predict that your company will last for a long time, right? So some companies may not be like that, like the tech companies. The immediate reward would be very high when it comes to a technological company, but the technology may get disrupted. So in so the discounting factor should be very high when it comes to investing in a highly technical company, right? So but if it is like a real estate company or something, maybe you can use a very low discounting factor because uh, most probably they would last for a long time, right? So and this discounting factor not only accounts for the uh, risk but also for the opportunity cost, right? So when you get a reward in the recent future, then you can invest this uh, recent future reward to something else, right? So if you get successful at moving your object to a certain level, maybe some other robot can do a certain change on that object while the object is holded by this particular hand, robot hands, right? So you can do some other stuff when you are successful in the earlier stage. So that is another reason why you should give a higher weight for the in the earlier stage, right? So not only the risk but also the opportunity cost, right? And like if you have learned about this in the finance, the same thing is applied for this for the reinforcement learning, where uh, this return is not calculated like this, but they are weighted with these discounted factors, and this total discounted reward is known as the return, right? So the return that you can get at time t can be represented by this form. That means you have to multiply the discounted factor, right? And then you have to multiply it with the reward at that particular time step. So you have to, from that time step to the end of the process, you have to get the sum of these discounted returns, this discounted rewards, which is known as the return of this particular action that you have taken in the given state. So when you have the when the agent see the state, it would calculate, it would think, okay, if I take this action, what would be the return or the total reward that you get by discounting it? So then the agent should take, right, the best action that he has, right? So once if we can decide what for each of the action, what is the return that he would get, like say like you have few stocks that you can invest, and once you find that a certain stock will give you the highest return, you would invest in that particular stock, right? So this is the same thing that is done by this reinforcement learning algorithm, right? So this return is similar to the time value of money, like what we have explained earlier. So this return, where you get at a certain state after taking a certain action, is known is given by this Q function. So in the reinforcement learning, this Q function is defined by when each of the when the when this agent is in a certain state in the environment, and if this agent has taken this certain action at, if he is in the state st and take the action at, what is the expected return given the state and the action? So for all of the in a certain time, that he would be in a certain state, right? So he has a set. He has a this agent has a action space. That means all the actions that he can take, but he can take only a single action, right? So once he take that particular action, what would be the expected return? That means after taking that action, what would happen in future? So you would get the total rewards that you get discounting with the time, and that return is given by this function known as the Q function, right? So this is so now you understand, right? So if you can find this Q function using a machine learning model, then you can uh, find which action would take the uh, give the highest return, and then you can execute that particular action, right? Because you can change the state, because state is given. You can't change the state. Only thing that you can change is you can take the actions rational. So if you can find for each of the action what is the expected return, so we action return also you can't actually, return is something probabilistic, right? So because we are not sure what would happen in the future, that is why we are discounting it with the time, right? We are exponentially decaying the rewards that you get in the far away future, right? So that is what we do with the discounting, right? So in that way we calculate the return, and we are trying to maximize the return that you could get after a certain time, right? After the end, until the end of the process, you calculate the return, and then you find which what is the return that you can get for each of the actions. Then if you can find this Q function for all the actions, then you can find which action would give you the highest return, and then you can take that particular action, right? So it's taking each of these actions for a given state and taking the highest value and finding that particular action is given by the policy function. So this is the Q value is given by the Q function, and finding the maximum return and for all the actions, and finding that particular action for the given state is given by the policy function. So the policy function is given by pi function, this in this symbol, right? So the Q function is given by Q, the policy function is given by pi, right? So the policy function is nothing very complex, but the policy function is finding the maximum Q value that you can get for each of for that particular for the given state, and finding that particular action, and that is the action that you should take, obviously, right, for that particular state. So this is the policy function that you can define, and if you can get this policy function, that you can directly take that action, right? This is a very simple thing to understand, right? However, when we are using reinforcement learning to to predict the next action that you should take, by the agent, there are ways that you can uh, two things that two basic ways that you can take, which is known as the value learning and the policy learning. Right? There are two pathways that you can take. In the value learning, what you do is you find the Q value. That means you find the uh, you calculate all the Q values or the returns for all the actions for the given state, and then you find the maximum uh, Q value for all the actions, and then you find the action that you give you the highest Q value or the highest return, and that can be used as the action, right? And but when it comes to the policy function, you don't have to. The idea is that you don't have to find the Q values for each of the actions, but you directly calculate the in policy function from the reinforcement learning, and then you can use this the policy function to directly take the action. So this policy is actually can be a probability distribution where you can take the actions. Right? So in this case, the value you take the highest value uh, action and you take the action. But when it comes to policy learning, you find uh, the rewards that the probabilities of getting the higher rewards in a probability distribution for each of the actions. So in the policy learning, you take the actions by taking a sample from the policy function, right? Not like the value learning where you take the highest Q value. In the policy learning, that you can take take you can sample from this probability distribution, which is the policy function for this particular state, and this becomes a stochastic process, right? So where you can't exactly say what in that particular state what would be the action that I should take, because this is a probability distribution. Most probably you would get the highest uh, Q value related action, but for some probability you would have some other actions as well. So and you can see that both these value learning and policy learning can be achieved with deep Q networks. So those are deep learning neural networks, and you can use deep learning networks for both of the purposes. So now let's look at a sample problem where this is a video game. It's a you can see it's a bit old game, right? So known as the Atari game. So this was done as a research for taking reinforcement learning to take actions to win this particular game, right? So the idea is that you can see this particular ball or the dot is moving like an object, right? It would hit here and there, bumping on these flat surfaces, and you can move this line here and there, or you can keep it as it is, right? Or either you can move it left or right, or you can stay in the same position. So this dot will hit on this plate and bump on it and hit on these lines. When you hit on in these lines, each of the block will get removed like this, right? So once you remove these blocks, you will get points, right? So you you have to decide what you should do, right? So whether you should keep it like this or you should move here and there or so. uh, it's not obvious, right? So I will not discuss more about this game, but the idea is that you can't definitely tell what is the thing that you have to do with this by moving this plate or just keeping it or whatever. Whatever you do, you should be uh, having a higher reward in the long term, right? So not the immediate return, but the long term return should be higher, right? That is what we are going to do with this example. We are not going to do it, but you'll see how it can be learned with the deep Q networks. So the one option to learn the outcome is that you can use a deep neural network to get the state or the where each what are the uh, existing blocks to be removed, and what are the location of this particular ball or that point, and what is the position of your plate, and all those information can be encoded as the state and given to the deep neural network. And for each of the movements, if you have taken the action to move it right, you can give this as an input, and you can find what is the return that you have got, which is the Q value. And you can learn this deep neural network. But when it comes to a problem like this, when there are many actions to be taken, it is not easy to learn this kind of network because it takes a lot of time, right? So instead of training a model like this, you can use another type of deep neural network to achieve the same value learning, where you only give the state information directly into the neural network, and then you learn what would be the return if you have taken the first action, second action, and nth action. So in this case, it would be moving right, moving left, or staying as it is. So for each of the actions, what are the returns that you have received? So those things can be trained in this type of neural network. In this case, we give the action plus the state and train the neural network to get the value for a particular action, right? So this one is more suitable when it comes to larger number of actions that are possible. So in this deep network, you have to find this is the loss function that you have to, right? So here you are calculating the mean square error loss function to train this neural network, right? Here what you do is that first thing is that you have to know that so once you have taken the action, uh, there would be some state, and there would be the action that you have taken. So those are represented by S uh, apostrophe, right, and A apostrophe, right. So if let's say S dash and A dash, right. So that target return is given by the Q value of this particular for the ground truth uh, state and the ground truth action. That means in this particular S dash state, when you have taken the A dash action, you might have uh, got the Q value, the maximum Q value, and this maximum Q values. Uh, so should be multiplied with this discounting factor and added to the return that was up to now, right? So you have to add that return, sorry, return that was up to now, and once you do it now, do this particular action, what would be the target return? This is the real or the target return uh, value that you have received, and the predicted return is given by this Q function QSA, right? So you can reduce this the predicted value from the target value and take the square and take the expected value, and this is the loss function of the deep Q neural network. So this is the theory behind it, right? So as if you take the summary of this deep Q neural network for the value learning, right? In the second type of deep neural network, you can see for each of the action, so the QA1, which is the action to move left, A2, which is to stay here as it is without taking any, without changing the position, and A3 is moving right. If in this particular state, if you have moved to right, your payoff would be 20. If you have stayed as it is, your payoff or the reward would be 3, right? If you have moved left, you would have rewarded nothing. So then you can calculate the policy, which is the maximum of these Q values, which is the 20, right? So the action which gives you the value 20 is the one with the action 1, A1, right? So, so you take the action 1 in the state, and then you get some observation. So whatever thing happen in the environment, the state will get changed, and this new observation and the new reward will be given to the deep neural network to make the second prediction. So this would continue again and again until the neural network is highly successful at playing this game. So this is how the Atari game is played with deep neural network. So what we have learned up to now with value learning is that each of the actions that you should take are discrete events, right? So either we should move left, right, or stay as it is. And because they are discrete, you can't predict any continuous value from this Q learning algorithm, right? With this Q function. And because the value that you select from this Q function, from the policy function, is deterministic, because it is the maximum Q value that you are selecting for all the, when a certain state is achieved, you should always take the same action, which is the highest Q value action. Because of that, you would not be able to learn what would happen when you take different actions, right? So this may be good at exploitation, because you are taking the maximum value, but when it comes to learning, this is not a good one, because you are not at least at in any time you are not trying to do the second action, which is A2, and see what happens. Maybe you would find that A2 would be highly successful, even more than A1. But you would not learn it with this neural network because you would always use this. You'll always take the maximum Q value from these discrete values and take that value deterministically. Deterministically means when you get the state as the input, you would always give the same. You would always take the same action, which is having the highest Q value. So it would continue as a loop, right? And it would not learn anything new at the end of the learning session, right? So because of that, policy gradient learning can be used instead of this value learning. So we will now look at it. So this is now what is mean by policy gradient learning. Instead of having the exact values uh, for exact rewards for each of the state, like moving to the right and certain value, here we have the reward probabilities. Like in this policy gradient learning, what you do is you directly calculate the what you do is you directly sample from a probability distribution, as I mentioned. So what really happens inside is that you would calculate the probabilities for each of these states, right? Uh, each of these each of the actions for the given state, right? So, all right. So what happens is in this given state S, you will have internally you will have probabilities for the action A1 for the moving left, for the action A2 staying as it is, and the action A3 for moving right. So these are the probabilities 0 0.9, 0 0.19, 0. So the addition would be 1, right? So 0.9 plus 1 is 1 because the probabilities should be added to 1, right? And what happens in the policy distribution is that it would be a distribution of policies, is distribution of these of each of the policies. So here you are not always taking a sample. You are not always selecting the action A1, but you would probabilistically select a value from this probabilistic distribution, right? So staying here would have some probability. Moving left would be having a higher probability. Staying right would have no probability, right? Because for the given state, there are actions. So what are the probabilities for moving to each of these actions? So because so what happens is when you are taking the output, what really happens is you are taking these probability distributions, which is a discrete probability distribution, of course. You would sample from this probability distribution, where in most of the cases you will have a left move. But because this is not a deterministic one, that means sometimes for with low probability, sometimes you would select the stay as the action, but this would help to learn new stuff. That means learn what happens when you are taking the minority probability actions, and the network would be able to learn from the other actions as well. So this is an advantage when it comes to the exploration path, right? So when it comes to policy gradient, it is much more suitable for exploration. Uh, not that it is bad at exploitation, but when it comes to the Q function or the value learning, in certain cases there would be very less or no uh, exploration, but most of the time it would be exploitation. But with policy gradient learning, there would be always the potential to for exploration, for unexplored uh, actions, to see what would happen. Obviously, that this would reduce the exploitation proportion, but this is good uh, because we maintain at least some probability for exploration. You can learn more and improve your model with policy gradient, because you directly get the select the action, not only by selecting the maximum uh, probability uh, action, but by selecting but by sampling from this probability distribution PAIS, given the state what is. So for all the actions, the probability should be 1. And when, so this policy function is a probability distribution, and you are taking a sample from this probability distribution, and this is how we take decisions from the policy gradient learning. And another advantage of using the uh, policy gradient learning is that you can use this for continuous functions as well. Right? So when it comes to Q functions, it was only possible to uh, learn the discrete outcomes, right? But suppose now we want to learn how fast or the speed and the direction where the plate has to be moved in the Atari game, right? Then you can't use the Q function, because the velocity or the direction plus the speed is not a continuous variable. Maybe you can quantize it into discrete variables, but this is not a good thing, right? So what you have to do is you have to map it in as a discrete. Map it, you have to use it as a continuous probability distribution, and this policy gradient learning can learn as continuous functions as well, where this probability distribution is not a discrete probability distribution, but it may be a continuous function probability distribution with a certain probability distribution function like the normal distribution. Right? So when you move into this direction, it is about move faster in the right direction. When it is in this direction, it is about moving faster in to the left direction. So by looking at this probability distribution function, you can see it is more saying more about moving to the left with the highest probability of moving at the velocity of 1 to this direction. -1 means moving to the left at 1 speed, right? Because you are not taking the speeds as a discrete variables. Now you can find the speed values in this continuous function, and then you can learn it. However, because there are infinite number of uh, value probability value sorry ac- actions that you can take, that means each action is, in this case, each action is corresponding to a particular velocity, right? But because we can't learn all the velocities in a deep neural network, here what we are trying to predict is not each of these uh, what are the probabilities for each of these velocities, but the mean value and the standard deviation or the variance of this distribution, assuming this is a normal distribution, right? So instead of predicting the probabilities for each of these actions, each of these velocities, each of the speeds in each of the directions, we are predicting the mean value mu, the variance sigma square. So it can be sigma or sigma square plus the mean. And from these two values, as you know, with mean and variance, you can define the probability distribution, which is the policy distribution, same as the earlier case in the discrete probability distribution, where now you can sample from this probability distribution and sample a speed at a certain direction. So here also to not be there's always room for exploration and not only exploitation. So this model can learn continuously with time by improving its model with the changing environment. Okay, this is all that we have to learn about reinforcement learning for this lesson. And there are a lot of things that there are many ways that you can do the reinforcement learning. There are different algorithms, there are different techniques, so which we haven't covered in this lesson. So if you have any questions about the lesson, you can ask.